Tutorial 9. In this tutorial, we'll be talking about metagame. Before we start, I would like to give credits for Kak Ricardo Antolis because I used his PPT from previous PKM on previous semester, but I did modify it to be English. Okay, let's start. So here we have the problem we're trying to solve in this video, which is motorcycle at Tidung Island. You can pause here if you want to read the problem. This is the continuation. And let's start. In metagame, we have 5 steps. So the first step is we define the players. Second step, we define the player strategies. Third step, we generate scenario. On step 4, we do scenario grouping. And on step 5, we do stability analysis. So on step 1, from the passage that we have read before, the players are local government, motorcyclists, and also tourists. So we have 3 players here. And on step 2, where we define the player strategies, each player have one strategy. So for local government, the strategy is to limit the number of motorcycle. For motorcyclists, their strategy is to reduce trip fare, and tourists, they just use bikes. So we have 3 strategies here, S1, S2, and S3. Please note that the local government actually have other strategy. They can limit the operating hours for motorcycle, but on this video, I will choose strategy 1 as limit number of motorcycle. You guys can choose to use limit operational hours for motorcycle. That's also fine. On step 3, we generate scenarios. So the rule of thumb is for the number of scenarios, we use 2 to the power of n, where n is number of strategy, because in previous slide we have 3 strategies here. So the number of scenarios should be 2 to the point of 3, which equals 8. So we have 8 scenarios here. I start from 0 to 7. I choose to start from 0, but you guys can start from 1 till 8. The reason why I choose to start with 0 is because on scenario 0, each of the players, the strategies, they don't get implemented at all. So for S1, this would be 0, S2 would be 0, and S3 would be 0. It is easier to keep track that way if I use 0 as the first scenario. So to make it easier for you guys, here's a trick. You guys can divide it by 2 here for the strategy 1, and for the strategy 2 you can divide it by 4. So divide it here, here, and here. And strategy 3 you just divide it by 8. What I mean is for strategy 1 you divide it by 2, so the first half you guys put 0 on it, and for the last half you guys put 1. And then for strategy 2 you divide it by 4, so this is 0 0 1 1 0 0 1 1, like this. And for strategy 3 you just use 0 1 0 1 0 1 and so on. This will make sure that you have a mixed scenario and you don't miss any combinations. Next, on step 4, we will do scenario grouping. So first we will be looking from the local government perspective. What we want is to be more environment friendly. So from the previous scenarios that we have, this scenario, we choose the scenario which will be the most preferable for local government. So by logic, it would be scenario 4, 5, 6, or 7, because they contain the number 1, which means the local government can implement their strategy, which is to limit the number of motorcycle. But we also have to consider what other players are doing. For example, in scenario 4, yes, we implement our policy, but the motorcyclists and the tourists don't do anything. But on scenario 5, other than we implement our strategy, the tourists will also use their bikes. So it is more environmental friendly, because who knows, in scenario 4 maybe the tourists do use other things. For example, the tourists use motorcycle and so on. So by logic, the strategy as scenario 5 is more preferable than scenario 4 for the local government. So with that, I rank the scenarios. So the first one, the most preferable one for local government is strategy 5, because I explained it before. We implement our strategy and the tourists use their bikes. It's very environment friendly. Second place, we prefer strategy 4 because we still get to implement our strategy. Next is 7 and 6, followed by 1, 0, 3, and 2. So for the ranking, is actually can differ between people. Just make it so it seems logical. For example, you would prefer, as a local government, you would prefer scenario 5 over scenario for example 2, right? Because on scenario 2, the motorcyclist can use their motorcycle and we don't do anything about it. So as long as the ranking is still logical, you guys can do it up to you. After looking from the perspective of local government, we see the perspective of motorcyclists and tourists. So as you guys can see here on the motorcyclist, because we use strategy 2, you notice that yes, the most preferable one is strategy 2 and 3 because there is 1 here. It means we can use our motorcycles freely. But on the third and fourth place, we actually choose strategies which don't contain a number 1. So this becomes logical when you see on scenario 6 and 7, we can use our motorcycle here in 1, but the local government, they restrict the number of motorcycle. So it doesn't make sense that we can use our motorcycle, but the government limit the number of motorcycle. So it's actually better that we choose scenario 0 because everyone do nothing. This is more beneficial to us rather than we can use our motorcycle, but it's limited. So it's not necessarily the first 4 should be 1 and the last 4 should be 0, because you have to consider what other players are doing. Same goes for tourists. The most preferable one in S3 is scenario 5 and 1 because the tourist can use their bike. But the next one is 4 and 0 because we don't do anything. But on scenario 4, the government actually implement their policy. But when in scenario 7, when we can actually use our bike, the motorcyclist can use their motorcycle. It's more preferable if we see it from scenario 4. Next, on step 5, we have to do stability analysis. So there is 3 terms that you have to know. The first one is rational. Rational choice is the best option with no unilateral improvement. The second is sequential. Sequential means all players have a more preferable options. And the third is unstable. Unstable choice is when a certain player have unilateral improvement and at least one of the other player have no change of the unilateral improvement scenario. So from these 3, we will continue later on so you will understand. But the point is, on step 5, we want to find the equilibrium. And the equilibrium should consist of combination of rational and sequential choice. There should be no unstable option in an equilibrium. So here we try to look back from the local government's perspective. So we have to make this table here on the upper side, and then on the lower side, this is just a copy of what we did in step 4. So on the preference, you just copy the ranking that you just made on step 4. So this row, you copy it to the preference. And then to fill out the unilateral improvement, you have to see it from the local government's perspective. So on S1, the strategy of local government, you close it. And then because we will fill the unilateral improvement for preference 5, you see which one of these scenario have the same S2 and S3 as scenario 5. So we want to find another scenario that exactly have 0 and 1. And that would be scenario 1. Because it has the same 0 and 1 on S2 and S3. So after this, we open again the row and then we choose, is it better for us as local government to is it better for us if we see scenario 5 or scenario 1? Of course, we would prefer scenario 5 because in scenario 5, we actually implement our policy. So we choose scenario 5. So for scenario 5, we don't have unilateral improvement. You do the same thing for 4, 7, and 6, and so on. But notice for when it comes to scenario 1, still the same. So you close this, and then the same one for scenario 1, where the S2 and S3 is 0 and 1, is strategy 5. But this time, the unilateral improvement should be 5, because the local government would prefer 5 rather than 1. So the unilateral improvement for scenario 5 is scenario 1 is scenario 5. Same goes for 0. The unilateral improvement should be 4, because if we compare between 0 and 4, here the S2 and S3 is the same, 0, 0, and on 4 is 0, 0. But scenario 4 is more preferable, because in this scenario we actually implement our policy rather than not doing anything. So we prefer scenario 4 rather than 0. Hence, the unilateral improvement should be filled with 4. So on. You finish these for every player. So from local government, from motorcyclists, and for tourists. After that, we compare these 3 tables that we have made. And then now we will try to look the rational, sequential, and unstable choices. So from the local government, we see on preference of 5, 4, 7, and 6 are the scenarios which is already the most preferred for local government. So there is no unilateral improvements. For motorcyclists, scenario 2, 3, 4, and 5, they don't have unilateral improvement. Same goes for tourists. So these choices with no unilateral improvements are called rational choice. So we put R to mark that these scenarios are the rationals. And then next, we try to see the unstable one. So from the perspective of local government, we prefer scenario 1, but in scenario 1 we prefer to push it to scenario 5. So there is a unilateral improvement for scenario 1. And then from this scenario 5, we see it from the perspective of motorcyclists. In scenario 5, it is already a rational choice from the perspective of motorcyclists. So if this happens, scenario 1 on local government is called unstable choice. Hence U, we mark it with U. And then next for this one, so for scenario 0, the local government would actually prefer scenario 4. We'll look on the motorcyclist. Scenario 4 is already rational, so this scenario is called unstable. Now we'll look at scenario 3. In scenario 3, the local government will prefer scenario 7. We'll look for motorcyclists on scenario 7. Motorcyclists prefer scenario 5. And from tourists, the scenario 5 is the rational one. So from this, we know that scenario 3 on local government is unstable. Next, for preference, for scenario 2, the local government would prefer unilateral improvement to scenario 6. For motorcyclists, scenario 6 is not preferred. Motorcyclists would prefer scenario 4. And for tourists, scenario 4 is also not preferable because they would choose scenario 5 instead. So we have come from a full cycle from local government, motorcyclists, and tourists, and everyone has a better option. They would prefer something else. So we can mark the scenario 2 from local government as sequential. We mark it with an S because we know that in this choice, everyone would have better options. So you do it again from the motorcyclist perspective. So for motorcyclists, you see it, you compare motorcyclists to tourists, tourists to local government. For tourists, you compare tourists to local government to motorcyclists. So it come back in a full cycle. And then you just mark it down which one is the unstable one, which is the sequential one. Here's the one for motorcyclists, and here's the one for tourists. So after you make these markings, you can tally those results. So for scenario 0, the result is unstable for everyone, so it's not an equilibrium for us. In scenario 1, there is one unstable, so it's also not equilibrium. Scenario 2 consists of one sequential and two rational, so it's equilibrium. Scenario 3, one unstable, not equilibrium. Scenario 4, one unstable, not equilibrium. Scenario 5, all is rational, so it's equilibrium. 6 and 7, they also have unstable, so they're not equilibrium. So as we can see now, the equilibrium is on scenario 2 and scenario 5. So here are the questions from the passage before. So from those process, we already have answers for question A and question B. So for question A, the strategies for each players, this is on step 2, we already make it. So the local government can limit the number of motorcyclists can reduce trip fare, and the tourists can use bicycle. Next, on question B, by using local government perspective, how much possible scenarios arise? Group the preferred, not preferred, and invisible scenarios. So we have 8 scenarios based on our rule of thumb. It's 2 to the power of n, where n is the number of strategies. So 2 to the power of 3 is 8 scenarios. And from the grouping we have on the previous steps, we have no invisible scenario of the game. So for the local government, we prefer a scenario which have number 1 in it, and the not so preferred one are the ones with 0, because it means we don't implement our policy. Next, for question C, how much sanctions for each preferred scenarios? So a sanction is where two strategy or more contradicts. So for this game, this is the tally that we did before. The sanction exists between local government and motorcyclists, because local government wants to limit the number of motorcyclists, but the motorcyclists want to reduce the trip fare. So as we can see here on scenario 6 and 7, there is a sanction, because when local government limit the number of motorcycle, but motorcycle wants to reduce the trip fare, there's a conflict between them. So the sanction here is when the local government do S1 strategy and motorcyclists do S2 strategy. This is 1 and this is 1. So no matter what will be done by the tourist, these are the conflicting parties and these are the sanctions. So there are 2 sanctions for this game, which is scenario 6 and scenario 7. In this scenario, there are sanctions because local government imply their policy, and the motorcyclists also do their thing, so it's conflicting. Next, for question D, which scenario will be the best suit for the environmental issue at Hidung Island? So as we can see from the tally before, the equilibrium are 2 and 5, but we choose scenario 5 as the best suit for environmental issues because it has the S1, the local government, and S2, tourist presence. So if we look back from the result here, in scenario 2, even though it's equilibrium, the government don't use their policy and the tourists don't use their bikes. It's just for the motorcyclists. And on scenario 5, it's the opposite of scenario 2, where the government do their policy and tourists do use their bikes, and motorcyclists don't get their reduced trip fare. So for environmental issues, it's better if we choose scenario 5. So the best scenario is scenario 5, even though the scenario 2 also have equilibrium. So when choosing between the equilibriums, which one is the best fit, you also have to consider what are our priorities. So when our priority is the environmental issues, we choose the best one is strategy as in scenario 5. Okay, that's it for the video. I hope you guys can understand. If you have questions, feel free to ask me or Alia. Thank you guys for listening to this video.